Okay, in this video I'm going to show you a proof of the cosine rule, which uses algebra that we've seen before. We'll start by drawing a perpendicular. Call that point D, and this makes two right angle triangles. In the first one I can look at the cosine of A, which equals the adjacent side, which is AD, over the hypotenuse, which is length C. This gives us that AD is equal to C times the cosine of A. Similarly, in the smaller right angle triangles, I can do cosine C, which is equal to the adjacent side, CD, over the hypotenuse, which is A. So CD equals A times cosine C. If we put those two together, what we have is that length B, the side B, is equal to AD plus CD. So B is equal to C cos A plus A cos C. Now this next bit is not really something that you would think of. I'm going to do it anyway, and you'll see why in the end. I'm going to multiply both sides by B. Okay, I'm going to multiply both sides by B to give us B times B is B squared, B times C cos A is C cos A, plus B times A cos C is B A cos C. That is where we'll finish for the first part, mainly because this result is going to be used with a couple of other results, and you'll see how the patterns are formed here. What I'm going to do is you do exactly the same process with the same triangle, and this time I'm going to put the the perpendicular in a different spot. That one E. So now, doing the same process as before, I can do this angle here. So cosine A is equal to adjacent AE over hypotenuse, which is B. This implies then that AE is equal to B times the cosine of A. Similarly, move over to the smaller right angle triangle, and with cosine B equals BE over A. This implies that BE equals A cosine B. Done. So this time C equals AE plus BE. So the length C must be B cos A plus cos B. And then we're going to multiply by, correct, by C. And we end up with C times C squared. We end up with C times B cos A. And we end up with C times A cos B. Something went wrong there. No problem. The result looks very similar to what we had before. And again, we're going to say that and do the same thing again. I did say it was fairly elegant, straightforward, and it's not done anything yet to upset us. And let's see how we get the next one. The next one, I'm going to put a perpendicular in the third and final place that it could go, which will be there. Let's call that F, and off we go again. All right, cosine B is the adjacent side, BF over C implies BF is C cos B. Change colour, smaller rectangle, smaller triangle. Here we go, cosine C is equal to CF over B, which means that CF is B cos C. So far so good. Therefore we now have A equals BF plus CF. So A is equal to C cos B plus B cos C. Final bit, multiply by A, well done, A times A is A squared, AC cos C plus AB cos, we've done it again, AB cos, where are we? C. Okay, so now I have three results doing three different perpendiculars, and they all look very similar. Let's take it from there now. So we actually don't need the triangle anymore. I'll leave it in the corner now. What I'm going to look at now is combining the three results together. And this is how I'm going to do the first part. I'm going to do a squared plus b squared. Well, we know from before that a squared is ab cos b plus ac cos b. Okay. Then we're going to add on to it. We're going to add on to it b squared, and b squared is ab cos c plus bc cos a. Now, what I'm going to do is I'm going to take away c squared. Again, this is the sort of thing you wouldn't think of maybe yourself. And so I'm just going to do this as a process through. So a squared plus b squared, take away the value for c squared. That's going to give us quite a long, expression. Here we go. AB cos c plus AC cos b. I'm just copying down the line from above. AB cos c plus BC cosine A. Take away c squared. And we already know that c squared is BC cosine A. And we're taking away AC cosine B. Okay, so let's just show you exactly what's happening here. This bit is a squared. This bit is b squared. And this bit is taking away c squared. So that's basically what we're doing. Okay, we have three expressions that we worked out, and we're just going to put them together like that. Why have we done that? Well, you can see, hopefully you can see, that what will happen here is you can see there's an AB cos C there, there's another AB cos C there, there's an AC cos B, take away AC cos B. So this and this are identical. So one taking away the other disappears to zero. We also have BC cos A take away BC cos A. So in other words, that and that cancel each other out. We're left with a squared plus b squared minus c squared on the left hand side. And on the right hand side, well, we've got two things that are identical. We've got an AB cos C added on to another AB cos C. Therefore, we must have two A cos C's. Just the name of it, B cos C. That's where we can stop, because we now can rearrange this in two different ways. And there are two useful ways. Okay, we can do two ways. First one, to calculate the length of the side. I'm going to do this. A squared, I'm going to start with the same one. B squared minus C squared equals 2AB cosine C. First move, I'm going to bring this to the other side. So A squared plus B squared equals 2AB cos C plus C squared. Okay. I'm now going to take this one to the other side. Well, that is one single term. So it's going to look like this. A squared plus B squared minus 2ab cosine c equals c squared. So that piece there was a positive term, and it's now a negative term. So you see there then, just by arranging it around, if I'm trying to find the length c squared equals a squared plus b squared minus 2 lots of a times b cosine c. And that's the standard formula for calculating the length of a side. The second way of doing this is to calculate the size of an angle. Okay, and to calculate the size of an angle, start with the same point we started with earlier. Okay, so to find the size of an angle. So this time, a squared plus b squared minus c squared equals 2ab cosine c. The bit that we will need to move is that. Okay, because cosine c is the cosine of the angle. That's what we're trying to find, the angle. If we look at 2ab, what is 2ab doing to the cosine c? 2ab is multiplying cosine c. So we end up with a squared plus b squared minus c squared divided by 2ab will give us cosine c. Okay, and that's just straight algebra, no problem with that. And so just rewriting cosine c is equal to a squared plus b squared minus c squared all over 2 times a times b. Wonderful. Done. Thank you.